Hey everybody. Hope everyone's having a great day so far. Let's see, my Tuesday actually has been pretty good. I actually barely done any programming yet so far today, so the stream will be a nice change of pace. Alright, so let's just get right into it, I guess. Alright, so we are working on pathfinding for our game, and really we want to allow the Lua scripts to be able to do the pathfinding, and so that's what, actually I can't talk. So we want Lua scripts to be able to call these pathfinding functions, and then but we don't want to actually implement these in Lua because it's relatively slow. So the C# part of our game is going to actually do the pathfinding. But of course, we're trying to make it as easy as possible for mod authors to use. And as we can see, I've set up this big map. And once we have everything hooked up, we'll do a couple types of pathfinding to test it. Obviously this is really simple because it's just a flat map, but there's basically 3 types of pathfinding we'll support. The first type is just every so a path from this monster to this monster, and then the second type is all the paths with a certain movement cost. So in this case, if we said they had to be 2 tiles out, then it would get all these hexagons, for example. And then we'll have a third type where we can actually say we want paths to these gray tiles, and so then it will just give us paths to gray tiles. So yeah, either a maximum cost to a specific monster or a specific function will tell the script when it's done. And the job of A* is, of course, for any of those situations, is to find the shortest path. So as I saw here, we have most things, we figured out all the use cases for it. In other words, we figured out all the ways we want scripts to be able to call the pathfinding. And now we started on the actual algorithm, and I think we're almost done with it. Hi Taco, good to see ya. How are you doing tonight? So here, whatever calls this pathfinder or creates this pathfinder will add a start node, and then from there it'll call this do loop, and it'll have a certain number of iterations that it'll do in 1 frame. And basically what it will do is pull the node with the lowest cost off of the queue and see if we've already visited that node, we won't do anything, but if it's a new node, we'll get all the neighbors for the position, and then we'll see if we need to add that path. So it looks like we didn't get too far yet. If the search type is a target, then we want to see if this neighbor is the target, then we know we're done, so we can clear the queue and add this end node. But things are more complicated otherwise. Oh, good to hear you're doing well. I'm pretty good today too. As I said earlier, I haven't really done much programming today. I had other projects, so it's nice to get a little in tonight. Okay, so I think that this part of the algorithm we'll actually use probably for each type, but I'm just going to write it in line here. I'm sure we'll clean things up. So what we need to do, first we need to get the cost. That's okay. I'm forgetting exactly how the heuristic is factored into here, but I'll look that up in a second. I know we'll need the cost for sure. So get cost from this parent to the neighbor. And then I guess we'll need the heuristic. And the heuristic, that's just what they call basically the guess of the cost from this neighbor node to the target. And the only important thing is the heuristic always has to be less than the actual cost. But that will actually be up to the mod authors to handle. Oh wait, not get neighbor. Get heuristic. From target. Actually, I got this backwards. It should be from and then to. I don't think it actually makes. Well, no, it would make difference because the cost could be flipped. But so for now, I'm just going to return 1. And since our cost is really simple, it's obviously less than or equal to the cost because it always is just 1. We'll want to hook this up to the Lua functions, but I'm not going to deal with that just yet. Okay, so I think I'm pretty sure how it works, but let me just look it up real quick. Use Wikipedia. Pretty sure. Okay, yeah, the G score is what they're calling the heuristic in this code. Okay, so yeah, it's just the cost that you put into the priority queue is the actual cost plus, oh wait, the actual cost plus the heuristic. Okay, so that's what I was thinking. And so at this point, should we check if the neighbor has been visited? I guess not. I mean, technically it would, because when this visited is, when this code runs, it just won't do anything. So, I mean, technically I think we could save a little bit of time if we checked right here, but just for the sake of simplicity, let's not. So now we need to add node, and we have the parent node, and the neighbor, and the cost is the cost, actually it's the parent's cost plus the cost to go from the parent to the neighbor plus the heuristic to go from the neighbor to the target. Okay, so we need to change this up a little bit because we'll keep on tagging the heuristic onto this cost value every time. Because how I have it here is that, yeah, we need to separate the path cost and the heuristic, I think. Might be a better name for this. Let's say guess cost to target. Yeah, let's just get rid of this, calling this a heuristic because it's a little confusing. I guess that's good enough. Okay, so now I just need to put another argument like that. And the Q node I don't think needs to have this guess at all. It just needs the cost so that we can add it on in the future. Okay, and is that it? I think so. Okay, so let's go ahead and pull some of these some of this logic out into separate functions just to clean everything up. What should I call this? This is basically to target. Handle neighbor target mode. Okay, that's fine. So I can rename this parent. I guess we don't really need to have this separate value right there. That'll simplify things a lot. So now we can just use parent dot head. Same here. Okay, so now we just need another function for each of the other types. So this will be max cost mode. It'll basically be the same, this part at least. So first, we just need to get there's no target here, so we just need to get the cost right away. Okay, so if, I guess I can go ahead and add this onto the parent's cost. Okay, so if, let's rename this total cost. So if total cost is greater than max cost, okay, which we don't have here yet. So, this is actually a good question. Should I add this neighbor that makes the search go over the max cost to the end nodes, or should I add the parent? I think, well, I probably shouldn't add the parent because, well, no, that would be okay, I guess. We'll have to worry about duplicates, but what I was thinking that, what if you had, I don't know, let's just do a simple graph here. So we have tile 1, or let's not do that, let's tile A is a cost of 1, but then this way is a cost of 2, and our max cost was 2, for example, or let's just say it was 2. So then if we move this way, then we'll go over the max cost. That means that A should be an end node, but we can also move to B, and that's not a max cost. So I wonder, okay, I think that we should always, yeah, we should never include any neighbors that are out of range. So yeah, we'll just add the previous. And maybe if there's duplicates, we'll just go back and get rid of them at the end or something. Now that I think about it, This works fine, I guess, but yeah, see, this will actually only find. We might change the way this works a little bit, because this doesn't find like any in-between paths. Let's see. So again, if we had something like one more, and our max. Okay, well, let's just for simplicity, we'll say the max is 3. So that means we go to B and to C, so the total cost is 2, and then when we get to D, it'll be over, so we'd be right here. And right now this algorithm would only return the path A, B, C, but here I also want paths A and the path A, B, so we need to like find the subpaths. What would be the best way to do that in this? Using in Lua. For path and paths, I guess we'll just have, let's have a function all subpaths. And then we'll also want to make sure dot get well, I was going to do something like get length is greater than 1, because we won't want just a path that's only contains 1, because that would just be moved to the position we're already at. I think, well, maybe let's wait and see how that works out. You could always have this get all subpaths not actually return a path where you don't move. Like for this example again, we don't really want the path that just is A, because that wouldn't make any sense in this regard. I guess I'll leave that in case I use it again. Okay, but anyway, we decided that we'll actually add the parent into the end nodes. So I guess do I want to? Yeah, we never want to have a duplicate in there. So let's see. It's fall, so I spelled that wrong. No, that's right, actually duplicated, okay. And end nodes. And then if node head equals parent head. Well, I guess we should use equals, not. I think we should use the equals function, not the operator. Well, we can actually just use the node equals function because it is slightly faster. Then duplicated equals true. Okay, let's actually invert this, so we'll have unique. So if unique, then we'll add the parent to the end nodes. And then we just don't do anything. But if the total cost is not greater than the max cost, then we'll add this neighbor into the list. So this actually yeah, there's no heuristic here because there's no target. So the guess is 0, and we just add it, or give it past the total cost. Alright, and then it's the last one, which is handle neighbor, terminate function mode. It's almost exactly the same, except instead of calling total cost, or instead of just checking max cost, we would call a Lua function. So let's see here. Private bool should terminate. I'm not really sure what we should pass here, so for now we'll just pass the node, and we'll I guess to prevent an infinite loop, I'll just return true. So I don't actually need the total cost yet. Actually, the terminate function, when we check to see if we need to terminate right here before we actually call the get neighbors. And then this code is really simple because we would always just add the neighbors. I guess that's pretty much equivalent to checking if we terminate here, except instead of adding the parents, we would just add the neighbor. But we will need to check if it's unique. Oops. Except at this point we don't actually have a node. But I guess that's fine. So node head equals neighbor. So then we'd add a new Q node. Okay, so I guess I do need the cost actually at this point. Okay, and the previous is the parent. Oh, except I reversed it, didn't I? Okay, and then yeah, if it's not a terminate neighbor, then we add this to the queue. Let's change this, add to queue. Okay, so since we, oh actually this is slightly different. I was gonna say since we search the end nodes list 2 times, we should put in a different function and consolidate code, but the logic here is slightly different. And here I also get the cost on both ends of this fork, so might as well move that out here. Alright, and yeah, we only use the guest cost and target mode. Okay, so I think that's about it. So handle neighbor max cost and handle neighbor terminate. And then we just clear the neighbors list. And after that we go back in the loop and pull the next node off the queue. Okay, so I think that's it. I guess we need to create the rest of these data structures here. And then we need to fill in how we'll get these values. Okay, so let's clean up this slightly. So these are like just data structures that the algorithm needs, while these are more arguments to the pathfinder. So we need to have an accessor for all of them. I guess we'll just have a simple callback for each of these. And there'll be some other script that will implement, or some other class that will implement actually calling the Lua scripts for us. I don't want to have to do that in here. Okay, so private does have a return value, so function, and the result goes at the end. So the first is get neighbors, so we'll just have the dynamic value for the node, and then it returns it. Oh, how does this work actually? It doesn't actually return anything. I guess we just pass it the list, and then we'll somehow populate it from Lua. So this isn't a function, this is an action because there's no return value, and this is get neighbors callback. Okay, and then I have a dynamic value from, to, and then double, and this is get cost callback. This will be the guess, cost, and finally we have the terminate function, which returns a boolean after we pass it dynamic value. Let's clean this up a little bit actually. Create accessors for it, and then I just need to plug them in down here. So okay, I just call it like this. Get cost. Get guess. Should terminate. Alright, so I think that we're done with this class now. It actually wasn't too bad. I thought sometimes A-star can be a little complicated, but I guess we still need to test it. Okay, so this is basically like the lowest level that actually runs the scripting or the search. But we need a couple more helper functions. Okay, so this will be like the Pathfinder manager that will have a list of all currently running Pathfinders. Maybe even not ones that are currently running. because we'd want to store, I guess I'd want to store some results, but probably we would store them in a better way than using that dictionary, so. Okay. And we'll have an auto controller here so I can hook up to the rest of the game. Basically, it'll work like this, where we have a claim for a specific asynchronous request type. Let's actually use the wait frame handler because it's a little bit simpler. There we go. So now I just need to clean up all the namespaces. This is Lua. Okay, well, I actually don't need this script, but okay, so we need another type, which is pathfinding. We'll actually have a couple of different functions here. Shortest path and the find all paths. Which I guess we'll just need to hook up into the coroutine helper. So what was the other function here actually? Yeah, we had this register pathfinding function, also in coroutine helper. Alright, so I just need to have a callback for those three. Request. I forgot what I called it now. Find all paths and then find shortest path. So actually, the first is the what do I call it? The register pathfinding functions. Doesn't really give me a good name for this. I guess we'll just call it function group name, and then the dynamic value for this is start, and then we can either have an integer here or a function. So I guess I could just rely on moving sharp to resolve these function overloads. Max cost. Okay, that's it. And we'll also have find all path except with closure for the terminate function. And then find shortest path is, okay, I don't know, now that I think about it, let's just use a dynamic value there. because we're already going to have to look into these starts to make sure that they're a valid type. So the function group name, dynamic value start, and dynamic value target. Okay, let's just create some callbacks. I also needed the one for the register function group. So this doesn't have a return value. We'll have closure. So get cost, closure, get guess, and actually I think I put neighbors first, so. Alright, so we have pathfinding all, pathfinding target, and then pathfinding func register. So need to create some fields for these, or not fields, accessors, and then I want to hide these from Lua. Okay, so now I just need to call these, basically pass along the arguments. Sorry, I'm having a hard time talking and typing tonight. So what is it not like about this? Oh, I had to have one more argument here. Oh, I see. I didn't even change the arguments. I just left it how it was. And now I'm gonna have to change the accessor values down there as well. And then this is just 3 closures. It's actually an action, not a function, because there's no return value. So just to make this easier on myself, I'll go ahead and regenerate the accessors. And again, hide them from Lua. Okay, so yeah, that's looking better. So pathfinding target. Pathfinding function register. Okay. So now here in the Pathfinder manager, I need to actually insert those functions. Okay, so let's say handle search all. Let's actually, let's get it. No, it won't. I was gonna say maybe it would generate that function for me. There we go. I put it in a weird spot, but. Finding target, so search target, and then what's this one, the register. Okay. So actually, let's start with a target because that's a little simpler. Oh, I see what's going on. I was trying to reorder. Okay, so we have the function group name and then start and target. So what we have to do here is, I guess first we have to figure out if this function group exists. Then we need to see if the start and the target are valid values. So what we decided is they need to either be a block position or an integer right now. We might support more in the future. Like I could see having to have the block position and maybe a move direction, and we definitely want to support that when the time comes. Okay, and then we should change this to pathfinding. I'll just return false for now. Okay, so we need to register the function group. Yeah, actually, I should have done this before I created separate callbacks here. I should just have a separate function group class. That would make things a little easier to pass around. This could even be a structure, but it's not good. Too fancy. So basically we want these three, but they'll actually be public. Okay, let's just take away the callback. Oh yeah, and I need to use moon sharp. Okay, we don't need the priority queue. So now we can just use the function group. And that way we want to have three separate values. It'll also make it easier to pass this to the pathfinder. Okay, so funcs.get neighbors, and then funcs get cost, and finally get guess. Okay, where was I? Pathfinder manager. So I guess we'll need to have a dictionary. Which would be string to function group. Okay, so let's just call this groups. Okay, and again, the search target and search all is going to have a lot in common. So I wonder what the best way. Let's just make. Well, okay, let's not worry about that yet. I'll just create it all in the search target, and then when we do search all, we can see what code we can pick out of here and share between them. So here, requested, pathfinding. So first, well, I guess we can set up the async request. Well, no, we should check to see if these are even valid values, so. Okay, so function group. So if function groups probably get value for group name to upper invariant. So if the function is not in this dictionary, then we'll need to throw an exception here because either the scripts didn't register this function group or there's a typo. Okay, so let's be a little bit more descriptive here. Pathfinding function group does not exist, or I guess it should call it, or say not registered. Okay, then we need another parenthesis. Okay, so the other thing that can go wrong here is that, of course, the start and the target are not supported types. And since we're already going to use this twice, I know that we'll need to pull this out into a separate function. So is valid node type so first we'll switch this, and if, or wait, not if, case, if it's a number, return true. The only other type we'll might accept as a user data, and for now we would just return value to object does not equal null, and value to object is block position. I guess that's an Lua interface, isn't it? It's actually board position. So right now we only support numbers and board positions, and the reason we had to do that is because the dynamic value, or there's no way to have Lua supply a hash function for a table, for example, which is a little unfortunate because we need to be able to hash these dynamic values for the pathfinding. So but we took care of that by getting the hash value ourselves if it's one of these types. Where did I do that actually? Yeah, the QNode, I think. Yeah, if it's a user data, yeah, we just go to toObject, and that will actually use the objects get hash code, which we know is a block position. And then otherwise we know it's a number, so we just use the get hash code function, which works fine for numbers. You can see right here. Okay, and then yeah, anything else we want to accept, so we'll return false. So if is valid node type start equals false, then we'll throw an exception. Past invalid value for start node. Must be number or board position. same thing for the target. I guess if they are board position, well, I was gonna say maybe we should like check to see that the board position is actually reachable. But no, because that would be up to the get neighbors to handle. Okay, so now that we know everything's correct, I guess we would just fill in the types here. So pathfinding. So what else do we need to insert in here so that we can figure out? So I guess we'll have an index for a specific pathfinder. So private, yeah, I guess we'll use dictionary int pathfinder. So the index would actually be pathfinders. Oh no, that won't work because we might delete some. So we'll need to have a count here. So next, finder ID. Okay, now we need to actually set up the pathfinder. So I'm not going to worry about caching these. Technically, you could maybe save a little bit of garbage if you did that. Okay, so let's not do that yet. End type equals target finder equals target finder functions equals functions. And we also need to give it the iterations. Not really sure. I don't think script should be able to set that. So max frame iterations. Let's go with 100. That might be a little high. And then we should probably have max total iterations. I actually meant to add that. That's just in case like a pathfinder is like stuck in an infinite loop. It'd probably be a little shorter. Okay, so let's go ahead and implement that real quick before I go any further. So how would we do that? So I guess down here we would say we need to keep a total iterations. Iterations. I guess this is one way to do it, but if I guess we'd only do that. We'd only care about this if the queue is not done. And if iterations is greater than or equal to I need to rename this, don't I? It should be max total iterations. Then we would just clear the queue. And also, I don't want to have duplicate code, so I guess we'll need to check if the queue is empty twice, but I mean, that's not a huge deal. So if queue count is greater than 0, oh, didn't see that extra curly brace there. Okay, so yeah, if there's still things in the queue, that means that we're not done searching. So we need to try and see if we've gone over the max iterations. If so, we need to clear the queue. And then if the queue is empty now, then we also need to clean up this visited just to clear up. Or clean up some extra junk. Okay. And find your max total iterations. Is that all I need to set here? So I set that, and those other two we don't need to include because they aren't needed for the specific type. So I guess I'll move this down just to signify that. And then of course we'll want to add this to the Pathfinder's dictionary. To increment the ID. Oh yeah, and then I also need to set the add start. Okay, so I think I'm done here. So let's see what is shared and what is not shared between the all and the target search. So this happens in both, this happens in both, this happens in both, this does not. So let's move this out. Well, I guess this part should be one function, which is basically validate. So private void, or no, it should be a boolean. Validate validate args common. I guess yeah, we'll just have these two. If we get all the way through, it would turn true. I guess we don't really need to do that because if any of these are invalid, we throw an error. So we can actually have no return value. Okay, so I think that's it. And then this part, oh. I don't have the handling script. Oh, so I guess I can just grab it this way. We actually need the functions. Okay, well, yeah, just to keep things simple. Actually, I don't want to do that because I'll have to remember to upgrade this to the 2-upper variant twice. Okay, so let's just return the function groups, I guess. and then we'll check that. So this is in common. Should I make... I wonder if I should make two separate types for pathfinding target and pathfind to all. Because one returns one path and the other one returns like a group of paths. I probably should, shouldn't I? If that's... So pathfinding target. Well, all we have to do is just pass this argument. I mean, nothing else is really different. But the actual type here will be the same. This is just for Lua to know the difference. Yeah, so this is good. And this is in common with them all, so I should pull this out to set up common. So what are these? It wanted the request. Oh yeah, because I guess I have to return it. Yeah, so I think this is the best way to do it. And then this. But I also need to pass the string for this. So string, Lua type. And then we'll also, well, this is just, I guess I could pass this to set in the Pathfinder, but really no reason. Okay, so pathfinding target. We're good there. So let's go ahead and copy this and add what we need to for this all. Okay, and I didn't name these right. And this will be the terminate. We don't have this, but we do need to check to make sure this is valid instead. And depending on what is actually in this dynamic value will determine the type as well. Yeah, so we need to make sure it's valid before we set it up, I guess. Okay, so we'll have either double max cost. And then a closure terminate function. I guess, yeah, to keep this simple, we could just have the end type here. So switch terminate type. And again, if this is a number, we're all good. Although I guess we should check maybe that it's positive. So if terminate number less than or equal to 0, we'll throw in an error. For max cost, number must be positive. Okay, and otherwise, if it's valid, then we can set these values up here. So max cost, that equals terminate number. Okay, so the other thing would be a closure, or is it function? And no way we can test this really until after we call it. So this is fine. No, that was right actually. And then anything else we'll want to throw an error because it's not a valid value for this. Past invalid, invalid terminate value must be a positive number or function. Okay, so then yeah, pathfinding all. We don't set the target. We would set. Well, I mean, I guess it doesn't really matter if we have like unneeded things in here. So we can just set the int or the max cost even if the type is terminate function. Because I think at that point max cost would just be 0, which is fine because it's not even going to use it. Oh right. Oh, how am I going to handle this? Because the finder actually I guess I'll just make a helper helper class. What is it not like about this? Oh. Okay, this should be a double because that's what Lua uses. Okay, let's see if I can figure this out real quick. Unassigned. Oh. Okay, so if in type, why does it keep on giving me the capital version? Equals terminate function, then we need to have some helper function. Let's see here. Yeah, now I think about it, I'm going to need to change how I did the function group because it actually needs to call like Lua functions and have a little bit of error checking, but okay, well, let's leave this for later. We'll need to wrap terminate function in a helper object to provide error checking and also convert this closure into the action or whatever the value is exactly. Let's see. Yeah, it needs to be a function that returns a boolean for a specific node type. And right now it's just the Lua closure, and so we don't know for sure what types it is. But besides that, we're done here. And then of course we need to actually register the functions, which is probably what I'll spend tomorrow doing. So this is get neighbors, get cost, and get guess. Okay, so things are starting to shape up now, I think. Did I add this simple pathfinding to the script? Not yet. So I wouldn't actually load it yet. Okay, let's just play the game and see how far it gets. Well, actually, I won't get very far because I haven't created that pathfinding manager yet in the subcontroller. Okay, so new pathfinding, pathfinder manager. So now it should at least be able to call those functions, though I think they'll throw not implemented errors. Yeah, got a Lua file. Attempt to index a nil at simple pathfinding 14. Oh, that's true. Yeah, the pathfinding functions actually need to be registered at load time. So we'll need to get back to that. Well, I mean, that'll be obvious. Do that. I'll just write a note here. Need to register pathfinding functions at load time. Because that means that data will need to go into the game data collection. Well, it's not really that difficult, just different. And then I guess there is a question, should we allow those groups to also be defined at play time and not just load time? I don't know. But anyway, I'm out of time for tonight. So thanks everybody for coming by and spending your Tuesday night a bit with me. Tomorrow, yeah, I will work probably mostly on hooking the Lua script functions into the pathfinding system, and hopefully we'll get to actually run it. I know there's a lot of build up. But yeah, I should be back tomorrow at around 8:30 Eastern. If you want to catch up on this stream, or if you missed any previous streams, I will upload this and all my other streams to YouTube. You can type !YouTube in chat or look at my channel description for a link. And similarly, if you want to chat with me and other viewers and game developers, you can check out my Discord channel with !Discord in chat, or on my channel description is an invitation link. So yeah, it'd be great to see you there. Right now we have a really small community, so always looking for some more people to talk to. But yeah, again, thanks everybody for coming out tonight, and I hope to see you tomorrow. Have a good night. Bye bye.